Hey everyone, welcome back to my channel EduVibe. Today we will start with the another topic of momentum and impulse, and basically we're doing the interactions in two dimensions as we started in the previous lesson. We will do the another topic of this, which is the vector resolution. So the vector resolution is more likely 11 physics when we do the vector addition. So it's a more likely this type of thing. So just refresh your mind at how can you do this in the 11th physics. We'll do one example from there and then we go on to the actual grade 12 physics related topic. So firstly, there are some rules to follow in this. So the use of a simple right angle trigonometry is required to solve the vector on its x and the y components. In the previous lesson, in the right angular questions, we will do with the x and y directions. We will more follow the directions where the direction goes, then we make the vector diagram. So in this, we more focus on the x and y components of this. In that case, we must be in degree mode, but no doubt we will also be in degree mode in the previous lesson too when we find the angle. So to add the vectors mathematically, the following step must be taken. So what are those? For each individual vector, when we have a x, like we have a one vector, so determine the x and y components using a trigonometry first. Then add up all the x components together to get the total x component, and add up all the y components together to get the y component. Sometimes we have that a 3 or a 2 or a 4 x component y components in the question, so we have to find their all their x and y components, then we find the total of this, then we go on to their directions. So ensure you set the convention of for direction. So if it's north, so it's positive, south is negative, east is positive, and west is negative. So it depends on the question when we deal with. So you need to take direction into account to adding the vectors too, but after taking the magnitude, after making the magnitude, so then you can take the positive signs to find the, because this is a scale when we're doing it. So make your right angle with total x and y components. We have to make the entire right angle from there, and then we find the magnitude of the vector by the Pythagorean theorem, and the direction of your vector with the determined using the trigonometric ratios. Like we use the tan theta always in that type of questions, but in like grade 11 phase you can use other tools, I think. So like in this question, this is from the grade 11 physics. So this is a refresh in your mind that how can we deal with those. So let's do it quickly. That is solve the vector 29.0 meter per second, which is 63.0 north of west, into its x and y components. So we have to uh, resolve this by in the x and y components. So firstly, we have something that is the north of west. So you know that how can we make this direction? So the north is the direction which is like this, and the west direction where the angle lies. So this is the west direction, and this is the net one. So this is your angle, this is your theta. The angle is given to you. So the angle is 63.0 degrees, and at 29.0 meter per second is this one. And we have to find this x component and the y component. We go the reverse of the previous lesson. So this is the hypotenuse, you all know. This is the base where the angle is there, and this is the perpendicular opposite side of the angle. So to find the firstly x component is base, and we have the hypotenuse. So this is like more like the cos theta. So the cos theta is equal to base upon perpendicular, that theta is equal to 63.0. Base we have x, hypotenuse is 29.0 meter per second. When we find so we get x component of 13.165 meter per second. So x component we find. For y component we have a perpendicular upon hypotenuse, so this is more likely the sine theta. So that sine is 63.0, perpendicular is y, and this is 29.0 meter per second. So y component is 29.0 meter per second, and we have sine of 63.0. So we get about 25.839 meter per second. So our x component is 13.2. We want to set this, and the y component is 25.8 meter per second. So this is your x component and this is your y component. How can we find in the grade 11 physics? This we deal with 11 physics. But now we have the more complex way, like we do in the previous lesson. We do like a bunch of calculations to get our magnitude and the thing which we want. So it's like this way we have to find. So this is the way we have to find our things to calculate. So this is more like the complex way to calculate, but let's do it. So a physics 30 student watched the following parts on a sunny day in the river valley. So they go 4.0 kilometers south and then they do 2.7 kilometer 32-degree east of north. We have to determine the displacement of the student and we have to draw the vector diagram as part of your answer. So there's a two vectors going on where first one is a 4.0 kilometers south. So the south direction, we know that south for the first vector, south direction is this, and they go to 4.0 kilometers per kilometers. So from here, that the south is the y direction because this is the y direction, you know. So our y1 is given to us, which is 4.0 over there, and our x1 is not there, so it's 0. It's nothing, so it's 0. So then, next one, our second vector is 22.7 kilometer and 32 east of north. So the east of north means what? So the east means over there, north means over there. So the east and north over there, and this is your vector addition. So this one is given to you, which is 2.7 kilometers. You know that east is the x component, so it's x2 now because we did x1 in the first one. This is your y2, and you know this is your east direction, and the east direction that opposite to it is your angle. So angle is 32 angle is 32 degrees, and we have the right angle over there. So now we have to find the x2 and y2 here, which we have to do a bunch of calculations to find it out. So for x2 we have 2.7 kilometers, and okay, so for h2 we have this thing is perpendicular because this is the right angle, this is the hypotenuse, and this is the base, and we have to find that p. So p is h upon p, which is sine theta. So sine theta is this, so we have to find the sine theta over there, which is 32. I do this like a short way, like we do firstly this, then we get to this. So I directly go to this to like a become the 12 physics question. So you know that how can I move to this directly. So when we calculate this, make sure you are in degree mode in that type of questions because it's a more likely the question where we deal with the angles. So this is 1.4307 kilometers. This is your x2. For the y2, I do over there. So for the y2, we have again 2.7 kilometer per hour, and now for y2 is the base, so it's cos theta, which is base upon hypotenuse. So now I can directly do the cos, which is 32 degree. So here's the thing that north goes up. So in first one we take south, which is positive. Now in that case there is a east, which we also take positive. But if we take south as positive, so we have to take north as negative. So here the north is negative, so we put this negative sign over there because it goes up, which is the north, and the south is positive, so north is negative. And we get y2 is in negative, which is 2.289 kilometers. So we get the both things like this one and this one, their x components and their y components. Now we have to add them up. So for the x, we have h1 plus h2. So h1 is 0 and h2 is 1.4307 kilometer. Make sure you take the rounded values for this. For h, we get about 1.4307 kilometers. For the y, you have y1 plus y2. Y1 is 4.0 plus y2 is a negative, so take it as negative. So you get y as 1.710 kilometers per hour. You make your x vector, you have your total x and total y. So what is the resultant one? So this both are in positive. So this means x vector, which is in east, so it becomes in east. So put it at east, which is our x, and that y is also positive, so it goes south because with it south is positive. So this is your y, and this is your resultant one, which we have to find the delta d. From x and y we have the delta d. This is your theta and this is your 90-degree angle. Now we have to find the magnitude. How can we find this? X square plus y square. So x square is 1.4307 kilometers square plus y square is 1.710 kilometers square, and we get a displacement magnitude of 2.229 kilometers. So the dimension we have to be in meters or kilometers, so we go on to the kilometers as until we have the same units. So this is your delta D, and we have to find the tan theta, which is y upon x. So this is a perpendicular upon base. So this is 1.710 kilometers and 1.40307 kilometers. So when we do the tan minus 1 of this, which is equal to theta, so you get about 50.084 degree. So what is the direction for this? So that theta 1 goes later on, when this is the east. So first one is south. So the south of east. And our final answer for delta D is, we want to set this again, so 2.2 kilometers and 50 degree south of east. So this is a distance displacement which we have to calculate, and they want the vector diagram. We made the vector diagram. In that case, we say it is the resultant one because we calculate them. So that's how you have to find this our questions, that this is the vector resolution. We use the vectors in this, not like a more likely not the directions. We use the directions, but this is the vector question where we find the displacements, where we find the distances from here. So that's all for this lesson. This is like a vector. So we do one or two more things in this, which is the non-right angle iterations and the explosions. So learning made simple with EduVibe. Learn smarter but not harder. Like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.